Okay, can you hear me?
Yes.
And let me put in screen share. Okay, it's in screen share now, correct? Okay. Okay. All right. Thank you, Miguel, for this invitation, and also thank you to Heidi for all the logistical help. It's been fantastic to listen to the previous four speakers. I think we have received an excellent overview from a EU policy perspective, a life cycle analysis and modeling perspective from Miguel, a fantastic net energy and carbon opportunity cost of land perspective from Tim, and the Brazilian cane perspective. I actually, I know this is about carbon footprint of biofuels, but and I'm as a LCA person, I think biofuels are a fantastic topic because I think it's incredibly complex and has helped as LCA community really advance LCA and make it more useful tool for public policy. Uh, but I'm also an economist, and so I'm trying to provide more of a you know there is more than carbon, and the reason why we have biofuels is not solely carbon or even primarily carbon, and there is a bunch of other things which I think it's worth always keep remembering. It's messy, it's not so neat as carbon accounting, as complex as carbon accounting is. There is, just very quickly, these are policy objectives. We might think these are legitimate or not legitimate as a, or some of these are political, but whether we like it or not, these objectives are real. Reduce oil consumption for reasons of energy security and volatility, develop renewable energy, develop domestic energy, support agriculture, employment generation, this is one technology or one set of technologies that doesn't require geographically concentrated minerals or new infrastructure, which is a big plus. And so we need to keep those things in mind. And different regions, policymakers in different regions place different weights on each of these perspectives. Like more environmentally enlightened policymakers may place greenhouse gas above or renewable energy about things. In other places, there may be other weights. Developing countries may have their own priorities, right? So it's really important to understand why these policies exist, and each objective. And it's important to say that none of these objectives requires biofuels. Okay, each one of these can be done without biofuels mandating them or subsidizing them. But we can sit here as academics or and say that policymakers are being inefficient or they are not being cost effective, but it's not a paradox. The policymakers don't sit in ivory towers like we academics do, right? I mean, so biofuels are simply an attractive one-stop shop option. You can be seen as doing multiple things with one policy, and there is a lot to be said about it. It's attractive, and a lot of us do things where we try to do multiple objectives at the same time, even if what we do is not the best for any single objective. So I think if you understand that, I think then we actually see why, where we see the problems with purely a carbon perspective, and that's what I want to provide here. Until recently, biofuels were the cheaper, simpler, mature alternative to battery electric vehicles. And I think Tim made some excellent points about the net energy. You cannot debate it. The inefficiency of biofuels there is no point in debating that it is, given that it's not energy efficient. But it is still cheaper than battery electric vehicles and hydrogen in many applications in transport. So having said that, I categorize the impacts of biofuels into three categories. The first set is those that are intended, what we intend to achieve, and we think it's a positive impact. We are achieving it, but it is hard to quantify or put a dollar value on it. So that it is renewable is indisputable, that it is domestic for many countries, if not for everybody. A lot of people, anybody with land and good climate can do it, and it stimulates agricultural economy. Okay, there is no disputing it. The only thing is it's really hard to put a dollar value if you're doing a cost benefit analysis. So there is no need to discuss this. The next set of categories are those that are intended but uncertain, and at best it is a weak benefit at best. So reduction in oil demand. Do biofuels reduce oil demand? They probably do. At least they reduce gasoline demand, even if they don't. 1 unit of gasoline may not, biofuel may not displace 1 unit of gasoline, but still. But the problem with oil is that gasoline is produced in fixed proportions. When you take a barrel of oil and you refine it, you get 40% gasoline or for petrol or for 30% diesel or whatever, right? That cannot be changed too much. So if we make biofuels, say ethanol, and we do nothing about biodiesel, or if we do ethanol and biodiesel and do nothing about jet, nothing about heating oil, nothing about plastics, naphtha, you still are going to need oil. There is no point in doing biofuels, and it won't, in the sense, no, there won't be any reduction in oil. So that's the first thing to remember. They may reduce gasoline demand. Reduction in fuel price. I think this is again an increase in supply of a new alternative source should bring down the price of oil, but this is costlier to produce. So the net effect depends on the subsidies, the level of the mandate, and the market conditions of oil, and which is very complex. Oil is not a perfectly competitively supplied commodity, right? We have done a lot of work on that. And then finally, reduction in greenhouse gases. And here it's very important to distinguish two things. Like we have said, there is the own life cycle emissions, which includes the direct land use change, which is everything. And I think it's quite likely that it's lower than petrol and diesel. Okay, we can again argue about it. Indirect emissions are highly uncertain. Okay, so this is the third category of impacts. So again, there is uncertainty in all of these things, but the point is, at best, they are a small benefit. Okay, the unintended and uncertain, but likely a net increase. And what I mean by increase is a worsening. It's a cost. It's a burden. It's a harm. So it's an adverse consequence. And so I want to touch upon 4 categories of unintended and uncertain impacts that are probably net harm or uncertain. I mean, the first 2 things are a little bit more complicated. So I want to focus on agricultural commodity price inflation. I don't want to use the food price inflation word. I mean, yes, it's popular. It sounds good to talk about food price inflation, and there is probably some increase in food price inflation. But I think we need to distinguish, and I'll give you some reasons why. The next is cropland increase. And yeah, indirect land use change sounds good. And it's a very important thing that I think Sachinjar and a lot of people have introduced to the debate. It's much needed that we have that. But, land is always changing. Okay, so what is salient about biofuels? So cropland increase is a more, it's important because I think the opportunity cost of land is not just carbon. There's a lot of other things that happen, good and bad. Water depletion, and air, soil, and water pollution from farm chemical use. Again, life cycle's contribution, life's LCA's contribution is burden shifting. And we talk so much about carbon, and this is a carbon webinar, carbon journal. But, the point of LCA is to highlight water issues and these things, which actually, there is a survey which says only 40% of papers even discuss non-greenhouse gas impacts, which is a problem. And some of those may be bigger impacts, but messier and harder because they are local things. So first, on agricultural commodity price increase, biofuels absolutely raise the price of agricultural commodities in the short to medium run. There's no debating that, right? I mean, you're increasing the demand for agricultural commodities. That has to raise the price in the short run to medium run. In the longer run, a lot of things can happen. Innovation can bring prices down and so on, but in the short to medium run, but impacts vary. It varies with crop, it varies with region, it varies with time, it varies for producers and consumers, and it varies between commodity prices and retail price of processed food. I'll give you some examples. There have been periods of rapid inflation, but these have dissipated rapidly. When prices rose the most, it was not solely biofuel. And biofuels are not an unmitigated disaster for commodity prices or for, So briefly, back, I did some work on price inflation. We have published some papers. We have a World Bank report that came out in 2007, 2009, just after the peak of all this. The essential things are that corn prices rose about 3-fold between 2005 and again, there are huge episodes between So this is about 20 years, right? When the biofuel experienced a renaissance in the early 2000s. So we have about 2 years of experience. And one of the biggest price increases was between 2005 and 2007, prior to the financial crisis. So corn prices rose threefold between 2005 and 2007. Rice prices rose twofold. Soy and wheat prices rose twofold, okay, between that period. The estimates of biofuels' role in corn and soy prices, or maize, again, I'm sorry, I'm in America, so I use corn, but maize, between 2005 and 2007 is between 15% and 75%. The 75% is the highest. There's only one study that does it. It's a World Bank report. But majority of the studies, both using modeling and statistical studies, put it between 15% and 40% or 35%. Okay, but the high end is 75%. Rice and wheat are not used for biofuels. There is very little of it anywhere in the world. And also, these are not substitutes to corn or maize. It's not a substitute to sugarcane. It's not a substitute to oil seeds. So those prices need to be understood for different reasons. Economic growth, weather shocks, and trade policies. If you react badly to a situation, it's probably going to make the situation worse, which is what happens with a lot of trade restrictions, but you can understand it. Countries are very, 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 food prices are a very political thing. So a lot of these things, there's a huge literature which shows there is economic growth. All these things, currency fluctuations were big factors, and bigger factors for rice and wheat. To some extent, it is true that if you expand corn and soy, you have less land to expand rice and wheat. But again, these are not really competing, except in a few places. So, and crop prices explain a small part of food prices. I'll say why. So, okay, some empirical realities. We never really cared to look at it because talking about food makes us all feel good. We feel like we are standing up for something very important. Oh, we care about the poor, and well, none of us really who was doing this is actually right. But it feels good to talk about rising food prices. It makes us feel good. If you look at maize commodity price today, right, and this is true for then as well. It's about $5 a bushel. It's again terrible units. $4 US dollars a kilogram. Okay. If you look at bulk retail maize price, 25 kg bag. Again, this is for the US, but again, maybe for the developing country, the share of processed grains in processed food is higher, so these shares will be a little bit higher. But let me talk about US, because corn is the biggest crop in the world for biofuels. The commodity price, the spot price, it's close to the farm gate price, in the price of bulk retail price of corn, a 25 kg bag is 2.5% today. The price of commodity in corn tortilla, which consumers buy, is 0.8%. If a household buys a 2.5 kg bag of corn grains, it's 0.4%. If you buy cornflakes, it's 0.4%. Less than 1% of your food price. You could say people buy corn. So even if you buy corn, it's 0.4%. So more work is needed in explaining the consumer food price effect. I mean, I don't think 1% increase in food price because of is something to, it cannot be, you cannot just extrapolate from when there is a 1% share. So even a doubling of corn prices will lead to a 2% or 1% increase in the price of food. If you believe that, of course, there'll be more because there is market power and so on and so forth. But the fact is, in processed food, and increasingly as people get wealthy, they consume processed food. Yes, there is some poor people who consume a lot of grains, but even for them, it doesn't explain it. Most of the modeling has been on commodity prices. And from this, we extrapolate to food prices. That's it's a big problem. I think there needs to be a lot more work showing how much of the commodity price is transmitted to food prices. You cannot just, extrapolate it. And even if you extrapolate it, you're ignoring the reality here. So higher food, and here's the other thing, higher food prices can be beneficial to farmers. A doubling of corn price or rice or wheat price is a doubling of revenue for a farmer. And according to this, probably it should lead to a 2 or a 3% or 4%, 5%, generous 5% increase in the price of food. Why are we saying farmers benefiting, doubling of income to farmers is worse than a 5% worsening of crop prices? Why should we care so much about food consumers more than food producers? There is a bias towards food consumers, and a lot of poor farmers, and FAO recognizes it. A lot of poor farmers, farm labor, benefit from higher food prices. Not to mention a lot of the other benefits of high food prices. So food prices are not an unmitigated disaster. Okay, we probably want to increase food prices because it helps you in a lot of other things as well. But of course, some people suffer. Second is cropland expansion. Biofuels will increase the demand for farmland without a doubt. But it does not necessarily mean deforestation. The first lands to be brought into cultivation will be idle farmland. It will, converting farmland, idle farmland or marginal land may increase greenhouse gases, and that's a concern. But there may also be other foregone ecological services. The Conservation Reserve Program in the US provides important water and ecosystem services, and that may be lost. And so it's not simply about greenhouse gas losses. There may be greater loss of other ecological services like water quality, soil quality, etc. It is hard to isolate the causal effect of biofuels when there are concurrent drivers, just like with food prices, economic growth, land development policies. See, all these satellite pictures say nothing, absolutely nothing about what is causing it. It's economic growth, it's land development policies. The West was developed because we wanted to settle the West. Europe and West deforested 200 years back, and now if the other regions of the world want to develop their land, more power to them, right? I mean, so we cannot sit and impose our carbon views on them, right? So we have to recognize there is land development policies, there is weather shocks, there's a lot going on. And so yes, satellite pictures look very good, but it doesn't tell you anything about what is driving it. Over time, productivity increases and land has been returned back to secondary forests. The entire US Northeast, a lot of parts of Europe are secondary forests. Yes, it may not be the same biodiversity as primary forests, but they're doing a lot of carbon then, right? So in the long run, we might recover it. Quickly, indirect land use change emissions are wide-ranging. It can be extremely pessimistic to extremely optimistic. And it's very wide-ranging. I think there was an excellent question, what model should you use? And I think Miguel gave a fantastic answer. It requires assumptions, all these, and again, search engine showed you, he showed there is about 2,000 assumptions, and I think absolutely right. I mean, these are models which have and he said there is at most a couple of elasticities or none is estimated empirically, and they change over time. And so none of these models have empirical basis. And so that by extension, none of these estimates have empirical basis. They cannot be verified. Anything that even if they had an empirical basis, you cannot verify them. It's not like just measuring the tailpipe pollution of a car or a smokestack. It ignores historical drivers of land use change. So median estimates suggest biofuels are not more GHG intensive than oil, even if you use land use change. So if policymakers want to say, give me a number for ILUC, you can choose a model which will give you a low ILUC. So we can find models and we can say that, 50% of the models give you low ILUC. And maybe that may be true, that may not be true, but who is to say? So this is tough. This is not easy. And so if there is ILUC, there is also IFUC. I don't want to pronounce it like ILUC. You can pronounce it yourself. I wrote a paper.
2 minutes.
Sorry.
2 minutes, Deepak.
Yeah.
Sorry.
So I know it's if there is just like ILUC, there is IFUC. It's the effect of fuel use change. Biofuels raise fuel prices. When they raise fuel prices, they reduce fuel consumption. That leads to additional emission reduction. So just like Sachin said, a lot of the emission benefits come from people eating less. If a very similar extension, if people drive less, that's a benefit. So no policy today takes IFUC into consideration. And just to be a little irreverent here, there is also potentially IFUC too. You can pronounce it yourself. It's indirect fertilizer use change. The point is not that we should ignore ILUC, but if we do ILUC, there's a lot of other things. So we can create a full employment act for people like us and keep writing a lot of papers. And so water, very quickly, water footprint is extremely important. there are 70% of global fresh water is for agriculture. I think that's a serious concern. We don't talk about it much. Farm chemical inputs, again, this is the biggest cause of eutrophication. So there's something called salience. Biofuels or agriculture contributes more to these causes than carbon emissions. So we should target these things, is what I'm trying to say. Summary, economic and political reality is we need liquid fuels. First gen is not the cleanest, but simple and mature. Second gen, costly, slow technical progress, needs R&D. Food price effects are overstated. Cropland expansion is a concern, but there is no empirical evidence that there's no empirical evidence for it, that it's how much of it is caused by biofuels. So the noble thing, the feel good thing is to say biofuels from crops don't sound good, and that may be right environmentally, but it's better to say that than justify it on the basis of numbers from models that are not suited for this. We need to use carbon accounting carefully, and this is the last slide. I'm sorry. I think we should, if we need these multiple objectives, there is a role for biofuels, but we need to ask the question: what is the best use of land? I think I agree completely with Tim there that there's an opportunity cost to land, but where I don't agree is the opportunity cost is not just the carbon opportunity cost; it's the opportunity cost period, which is carbon with one of the opportunities. So we need to look at the overall picture. Okay, and we need to use more of life cycle based standards. Indirect emissions needs to be addressed better, but I think overall we need to make agriculture less harmful. I think that's the whole thing, and we need to target land policies. A bunch of papers, the touch one and nature energy one, and you can look at it. Yeah, I think that's it.
Thank you very much, Deepak. Very useful summary. The floor is open for the audience. We don't have any comments or questions in the comment box, I don't think, other than what are the challenges for the production of biofuels in Tamil Nadu in India. I'm not sure if...
Okay, I'm from India in Tamil Nadu. I did a little bit of work like long time back, so it'll be immodest of me to say what has happened in the last 15 years. But again, I would say as somebody who with Tamil Nadu and all the political issues with water, with Tamil Nadu grows 2 or 3 rice crops a year. Water is a huge concern, and I guess essentially I think in water scarce areas it will be irresponsible to grow biofuels. So I think in water scarce regions, water has to be the primary concern, and so to the extent we can use residual biomass or use and again there's the bioenergy may be a better option than biofuels in a lot of places because you have biomass. And so I think it goes back to what is the best use of land. Yeah, I think I'll stop there because I can't say anything.
Thank you. I have another question. What would it take to understand the causality for the remote sensing observation that land clearing is increasing?
Yeah,
what type of needed to understand the drivers?
Important question. I guess I'm not a remote sensing person, nor am I an econometrician. I know a little bit, but you need to combine econometrics. Try to use the most sophisticated of econometrics. How do you isolate the non? Again, for the reasons we received, the mechanisms by which ILUC happen, like Miguel said, right? It may not be directly the crop what is pushing, right? If you obviously are planting in those remote sensed areas, if the growth is happening in biofuel crops, that is a clear indicator. But even that, again, how much of that is due to increase in demand for the crop due to economic growth, rising income, demand for meat. So we absolutely need those studies, but I think we need to go beyond those studies. And I think this is where my pet peeve about data science is progressing very fast because of computational capacities, but our theoretical and our conceptual capacities don't grow that fast. And so we need a lot more work on what kind of models are we applying to those data. So I think more work needs to be done there.
Thank you very much, Deepak. Before we proceed with the last presentation by Hans, I would like to open the floor for any questions you may have for Tim. Tim has to leave us soon. So if anyone would like to ask him a question or make a comment on what he presented, you're welcome.